These are the notes for 5.4 and 5.5, which we're starting to factor trinomials. In these sections of the book, we are only factoring where there's no number here in front of the x squared or the first coefficient is 1. Basically what we're doing is the opposite of what we did before. Last time I gave you the sides and you had to build the resulting rectangle. This time I'm going to give you the pieces of the rectangle and then you'll find the sides. So what you'll do is you'll take the pieces and you need to work with them to figure out how they can make a rectangle, and parts need to match up. Okay, so you can see here I'm using these to build a rectangle. Once I have my rectangle, now I need to figure out what are the factors. So I figured out how this could make a rectangle. What are the factors? Okay, well, a side that matches here is x and 1, x and 2. So you can see what we're trying to find here is if this is the area, we're going backwards. If this is the area of the rectangle, what were the factors? And I did that here. Let's see. One more quickly. Again, you can move these and you can try these on your own. This one actually is going to take a little longer than I intended. But if you go to the Algebra Manipulatives link in Canvas, you'll be able to find this. And again, go over here to factoring trinomials and you can practice building them. And we're going to use this idea of how we built them in some of our ways of factoring. So I'm going to go back to the first slide. Factoring quadratic trinomials. Here's the trinomial we're trying to factor. Okay. Last time when we did the area model and we multiplied, we wrote the factors on the side and found out what the area was by doing this. Same idea as when we built with the tiles. So we always had the x squareds in one little corner. You can see that here. And then we had the ones always in another corner. And these green x's were spread out. So what I did is, what would multiply to be x squared? Well, x and x. Okay, and then I said, okay, well, what will multiply to be 7? Because down here, that's what the area of this one is, 1 and 7. So if you do that right now and you multiply that out, you would get 7x and 1x. Now when I add those together, I get positive 8x, but what I want is negative 8x. Well, there's a pretty easy way to do that. If I change these both to minus, negative 7 times negative 1 still gives me my positive 7, and now I have the negative 8 I need. So your factors are x minus 7 and x minus 1. So it's using that same idea we used before when we multiplied. In reverse distributive model, this one might be a little more complicated, but I do have people that think this makes more sense. Again, you don't need to know both, you just need to know one that works for you. So we're going to look for numbers that multiply to be 7, which is coming from this last term, and add to be negative 8, which is the coefficient in front of the x term. And I found two numbers to be that, negative 1 and negative 7. So the next thing I did is that negative 8x, I split that up according to the numbers I have here. Negative 1x minus 7x is still negative 8x. It's the same thing. And I split it up based on the numbers I found here. Then I looked at the first two terms and the last two terms. I grouped those together. Notice I changed the sign here because if I distribute the minus, I need that to be a plus 7. So notice this is like a negative 1. We did this before, so that's why the sign changed here. I factored the greatest common factor out of each set of terms. And then I said, okay, what's the same in each of them? What's this common factor in each of the underlined? X minus 1, so I factored that out. And I was left with, when x minus 1 is gone, I'm left with x minus 7. So same answer as before. On the next slide, I'm going to talk through another set. These are two different problems, but I did them in two different ways. If you want to push pause and just try to do these yourself, you can use either method that works for you. So push pause, give these a try, come back and check your answer. All right, in this example, for x, I have the x squared and then minus 12, and again, they're coming from here. And remember when we built the area models, the x squareds were in a corner, the ones were in a corner. So now we need to figure out how to split up those rectangles. So we need these two parts to multiply to be negative 12. So you might try negative 3 and positive 4. Okay? And when you try that, nuts. That didn't work because these two, when I add them together, I get 1x. I want 4x. So that didn't work. Let's undo that. And again, you'll start to look, be a mathematician, and start to look for patterns in the numbers you're getting and the numbers that you were given. The numbers that will work here are plus 6 and minus 2. Okay. When I do that, I get 4x, which is what I needed here. So my factors I would write down are x plus 6 and x minus 2. And you can check it by multiplying it back out and making sure you get this trinomial. Now in the next one, again, you could do this one with the area model, but I just did it with the other method just so people could see both. So again, I'm asking what multiplies to be negative 3 and adds to be negative 2, negative 2 coming from the middle coefficient. I found two numbers that met those restrictions. I rewrote the expression. Again, it's the same thing. It means the same thing. Negative 3x plus 1x is still negative 2x. I just split it based on the numbers here. I grouped the first two terms and the last two terms. I factored out the greatest common factor from each. When I do that, now I have x minus 3 in this term, x minus 3 in this term, so I factored that out, and I was left with x plus 1. On the next slide, I'd like you to push pause. I would like you to try these and then come back to check the answers. These are the answers to this slide. In this one, you may have spent quite a while trying to figure this one out. This one ends up being prime. You're not going to use decimals or anything. The best this can do is 1 in itself. And just like a prime number, like 2 or 7 or 11, its only factors are 1 in itself. So when we can't factor it, we're going to say it's prime. So this is an example of a prime. And then these are the answers to the other two. Again, your method doesn't matter. That you got to these answers is what hopefully you got to. If you have questions with it, bring me the work that you did. Let me see it and I can help clarify for you. So this is factoring trinomials, first coefficient, not 1.